So today I'm happy that Rich, who's the Chief Technical Officer, is going to be giving a webinar today, and he'll be about the importance of mathematics education for development through economics. So without further ado, Luis. Thank you so much, Luis.
Thanks, Deepa. It's a pleasure to be with you. Look, part of my argument why numeracy matters to economies, but part of the argument is intrinsic to why educators. Sometimes we have good evidence on education in general, sometimes about numeracy, and I'll try to point out numeracy specific evidence, but I also want to talk a little bit because it's in that aspect as well. And I want to introduce it by saying, what is it about economists and ministries of finance? There's a myth. I claim that it's a myth. Marks don't realize that education is, and I can't count the numbers that a of education or a deputy minister told me, "Hey, Luis, go talk to the Ministry of Finance people. You're an economist. You can go. Can't you just go and explain to the Ministry of Finance people that education is that we need more money and all this kind of." But the fact is that economists don't agree on a lot of things. But one of the few things that economists really agree on is that education is an investment, and particularly math. And there are many ways, and we'll go through that in the. But there's a big cap. Economists and ministers of finance, while they think that education investment, that spending is as investing, and by that same token, they don't think that most ministries of education are good investment managers, and so that's where the slip up is, and we'll present a little bit of the evidence on that. So the rest of this presentation, how we know that education is an investment, focus on why math education is particularly a good investment, and the that we have about it. I'll welcome in Deepa, since I can't see the chat. If there are questions in the middle, please just say them to me, and that way we can.
Sure, yeah, and if anyone has any... Sorry, I didn't mean to interrupt you. But if anyone has, they can type them into the chat box, and I'll raise. Yeah, no problem.
And then I'll take a minute to show a few graphs to explain why spending is not the same thing as investing, and why spending does not lead to results. Because I think it's important to, in that sense, to understand what it is that economists or how they why they do to the various arguments, and then some ways in terms of what is needed so that spending to investment and does lead to results. And some of that will be old hat. I think it's nice to have all the arguments. So there are basically three types of clues as to how education contributes, and these are analyses that economists have done looking at any given economy over time. So looking at the US for the last 150 years, or looking at Japan for the last 100 years, or the UK or something, but also comparing countries to each other. And basically what economists started discovering was that the economic growth of countries was faster than could be explained by just looking at the growth in machinery, physical infrastructure such as roads and ports, plus the labor force plus the growth in land utilized. So there was a residual, what economists call a residual, started showing up in the economic statistics, and that began to be called total productivity. I'm using shorthand here, and probably I would be kicked out of the Economists Union for using so much shorthand, but basically what they started to discover is that there was this kind of residual that you needed to take into account. And that residual correlates very well with growth of human capital and skills and so on. And a kind of stylized fact is that an increase of education of 1 year for all workers amplifies or deepens of the workers, and it's like adding 6 workers with less education. So a worker with 1 more year of education is like 0.06 more workers, if you will. And that's how it shows up in economic growth. And it's pretty dramatic. I'll show you some data from Japan, in particular from Japan's fast growth period. Don't want to look so much at the stagnating Japan of the 90s and 2000s, but when they were really booming, their total economic growth was about 4.7, and the growth in machines was 2.5%. The growth in labor used was 1.1%, and they didn't increase their land coverage, so we can take that out of the equation. But if you add up 2.5 and 1.1, you only get 3.6. And yet the total growth was 4.7. So where was that other 1.1 residual coming from? And it basically comes from productivity, including skills and education. That's that mysterious or residual other 1.1%. And that had a lot to do with the huge investments that Japan made in the 50s and 60s were then showing up in the 70s and 80s as a tremendously increased productivity of the labor force. And that's pretty well established. So that's one type of evidence. And you can look at the types of education that increased the most and see whether it was science, engineering, and math. And that way you can begin to attribute to those particular sectors. Now, there's proof or two, which is looking at people's earnings. Here, the basic and simple observation is that educated people earn more. And you can make statistical comparisons, labor market surveys, using labor market surveys. And the rate of return that you can calculate the rate of return to education just as if it were an investment, a financial investment, because you can look at the increased earning from more education. For every extra year of education, people earn a little bit more. But of course, every extra year of education also costs a little bit more because the state, the government has to put money out for hiring teachers and buying books and so on. And also people are giving up some of their work while they study. So the income that they give up while they study and the costs of actually hiring the teachers, that's the cost side of education, if you will, summarizing. But then how much more money you make later, that's the benefit side. And then you compare, you basically come on top, you put the cost on the bottom, you calculate the ratio. I'm exaggerating a little bit and simplifying. And this picture kind of illustrates it. The vertical axis shows the earnings, so it shows money. And the horizontal axis shows time or age. And basically you can see on the left-hand side the primary school for the 6 years or so, 6 to 12, you incur costs because you're not working on your farm or you have to hire teachers, and then you get the benefits in terms of increased income and increased productivity. Increased productivity to the society, increased income to the individual. Secondary, what happens secondary, you have costs roughly between ages 13, and the costs stay and deeper because somebody that's in high school is working and is working with a primary school with a primary school education, so their wages would have been higher had they worked. So the costs or benefits are also higher because secondary education gives you even more skills. That's how you sort of compare the benefits of investing extra in education in terms of years of education. And what we find in a lot of developing countries is that the financial rate of return to education is around 10 to 20%. It's a good investment if the stock market did that. So education is typically a better investment than the stock market, or it's a better investment than a lot of other, than say investing in airports and ports and power plants. It's really one of the best investments around. And it's especially true for those with training in math, science, and engineering, or I guess as they say in the US, STEM, science, technology, engineering, and math. For instance, a recent European study that covered, I think, essentially all of the European economies showed about a 7% markup for STEM education over other education. And that's even taking into account the fact that STEM often costs more, especially at the university level. So even discounting for the fact that it's more costly, or that it can be more costly, there's a 7% markup for STEM education over the rest of education. And again, this is done by using labor market surveys, asking people, what did you get educated in? How much money do you make? And then estimating how much it costed to educate them. So that's also pretty strong evidence. And there are lots and lots of debates about this, but I think in the end the basic conclusion is that these data are solid. For example, some people debate, well, school actually train people doesn't actually increase. Schooling is just a sophisticated way of selecting those that are really talented. If you have the patience to get educated and you have the discipline to do well in the test, then you're to be a good employee. And it's not anything that you actually learned. It's just that education is a huge selection machine. But that's, some people believe that, but I think most economists nowadays believe that education is productive. It's not a selection tool. So there are also non-economic and social political benefits. I want to stress that it's not just the benefits. A guy called Wynn at University of Illinois quantified a lot of the effects, cut and pasted this from locations, and you got better public health, population growth, democracy, crime rates, substance abuse, less incarceration, all kinds of stuff. And those economic benefits, so they'd be social benefits that also have economics. And we even on things like social cohesion. People that are more educated tend to display more solidarity with beings, human, and more trust. That's actually from a study that I myself did. And clue 3 is more about quality, because most of what we've been talking about is years of education in general education, or years of education in math. But we also have evidence that that some recent research by people such as Hanushek and Wozman, that quality and what you actually learn matters even more. And in some of these studies, quality is proxied as learning outcomes in mathematics specifically. And the evidence is really strong about how it contributes to economic growth. This shows a graph, for example, of test scores in math on the horizontal axis and conditional and economic growth on the y. And this is conditional on a lot of other factors. So it's teasing out other such as investment in or investment or quantitative growth in the labor force and so on. You can see that there's a very tension there with Asia being the stars and sub-Saharan Africa sort of the laggards. And it also makes a huge difference. If you look at score inequality on the horizon and the earnings inequality,
Thank you, Luis. Hold on. I'm going to start my webcam. 1 second. Okay, thank you so much, Luis. That was a great presentation. And you have a couple of questions that are coming up. Carmen wants to know if you have a reference for the European study, the slide that you did on STEM. She wanted to know for that. Okay, perfect. Thank you. And Danston, who is connecting from Nairobi, he wants to know if, is education still an investment in cases of unemployment? Okay, thanks, Luis. Ron, who is connecting from Mexico, he has a question. He says, in your opinion, how could we deal with improving education levels when a huge percentage of students in Latin America attend schools with nutrition problems? Okay, thanks, Luis. Luna from GIZ in Germany has a question. She says, thanks a lot. Are there any examples of good investment managers in education ministries with a good databases? And Jeff Davis also says, a great question, Lina. What low-income countries are showing both improved education results and economic growth?
features, I would say. So there's Uruguay would be a good example of a middle income, and Kenya of a low income country where I think they're using good measurement and some techniques. Still pretty far as in the Finlands, but pretty.
Okay, thanks, Luis. Are there any other questions for Luis? I don't think there are any more questions, Luis. Thank you so much for giving the presentation today. And we will share the practice site. And Luis, you also mentioned you had some references that you could show me, right?
Yeah, I can. I mean, just for copyright purposes, I share the link. And I think these are public domains, but if I share the link, I think if somehow somebody's intellectual property, I think I can share the link. I might not share the paper itself.
Okay, well, we can have the reference, and then people can look up the paper later on.
If I found it on the internet, so can anybody else. So I'll just share the link.
That's true. That's a good point.